Welcome, data architects and engineers. Today we are mastering semantic model generation for Snowflake Cortex Analyst. We'll explore how to craft lightweight YAML files, store them securely in Snowflake stages, and give your AI the exact business context it needs to generate flawless SQL. Let's get started. Let's begin by defining what a semantic model actually is in the context of Snowflake Cortex Analyst. At its core, it is a lightweight YAML file. But conceptually, it is the brain that gives your AI business context. When a business user asks, "What is our net revenue?" the AI needs to know exactly which tables to query and what net revenue actually means in your specific organization. Raw database schemas completely lack this context. They just have table and column names. The semantic model bridges this gap. It acts as a universal translator, mapping user-friendly business terms, synonyms, and complex metrics directly to your physical data. By providing this file, you empower Cortex Analyst to generate highly accurate text-to-SQL responses without hallucinating or misunderstanding your data structure. Take a look at this flowchart to see where the semantic model fits into the architecture. On the left, the business user submits a natural language question to Cortex Analyst. Instead of guessing how to query the database, Cortex Analyst consults the YAML semantic model in the center. This model provides all the necessary business context, join paths, and logic. Equipped with this precise map, Cortex Analyst can then generate highly accurate SQL and execute it directly against your Snowflake physical tables. It is a seamless flow that protects data integrity while democratizing access. Why should your engineering team spend time building a semantic model? The biggest reason is precision. Generic AI solutions often fail at text-to-SQL because they don't know your business rules. The YAML model explicitly tells the AI exactly how to calculate a metric and exactly which columns to use for a join. This eliminates the guesswork. Secondly, it saves your team from massive operational overhead. Instead of building your own complex, fragile RAG pipelines to inject context into an LLM, you just provide a simple file. Cortex Analyst manages all the agentic AI routing under the hood. Furthermore, the model enforces security. By only declaring specific tables and columns in your YAML file, you strictly bound what the AI can see and reason about. Finally, because it's just YAML, you can easily check it into version control alongside your standard DBT or data engineering code. This comparison diagram perfectly illustrates the value proposition. In the top track, we see the generic AI approach. Feeding a raw schema directly into a generic LLM almost always leads to hallucinations, incorrect aggregations, and bad joins. It is risky. In the bottom track, the Cortex Analyst approach introduces the YAML semantic model as the foundational layer. By routing the request through Cortex Analyst using this rich, curated context, we guarantee governed, mathematically precise SQL generation. It transforms a risky AI experiment into a reliable enterprise analytics tool. Let's dive deep into the actual structure of the YAML file. The file is highly organized and human-readable. It starts with basic metadata, the name and description of the model. Then, we define logical tables. A logical table maps a business-friendly name directly to a physical base table or view in Snowflake, specifying the exact database and schema. Within each logical table, we define dimensions. Dimensions are your categorical data used for slicing like region or date, and you can add synonyms here so the AI knows that geo means region. Next are the metrics. These are your quantitative KPIs. You provide the exact SQL expression required to calculate them, such as sum of revenue. Finally, you define relationships. If a user asks a question spanning multiple tables, this section tells the LLM exactly which keys to use for the join, such as joining orders to customers on the customer ID. This class diagram breaks down the YAML hierarchy visually. At the root, we have the semantic model YAML object containing global metadata. This root object is composed of logical tables and relationships. Inside each logical table, the definitions branch out into dimensions for filtering and metrics for aggregation. The relationships class sits at the model level, defining the connective tissue between the various logical tables. By structuring your YAML file precisely this way, you provide Cortex Analyst with a perfect, unambiguous blueprint of your enterprise data architecture. Once you have written your YAML file, where does it live? It must be uploaded to a Snowflake stage. Specifically, you create an internal stage within a database and schema and upload the YAML file using SnowSite or the Snow CLI. When your client application makes a request to the Cortex Analyst REST API, It passes the fully qualified stage path to this file as the semantic model file parameter. Security here is twofold and robust. First, the user executing the query must be granted the Snowflake.Cortex user database role to invoke the AI. Second, they must have explicit read privileges on the stage where the YAML resides and explicit select privileges on the underlying physical tables referenced in the model. Finally, keep in mind there is a 2 MB size limit on the YAML file, which encourages you to keep models cleanly scoped by business domain rather than building one monolithic file. This architecture diagram shows the deployment and execution lifecycle. On the top left, the developer uploads the finished YAML file to the internal stage. At runtime, the client app sends the user's prompt along with the stage URL to the Cortex Analyst REST API. Cortex Analyst immediately retrieves the YAML from the stage. Before generating or executing any SQL, the system hits the security policy node to verify role-based access control. It ensures the user has rights to the stage and the tables. Once authorized, the query securely runs against the physical tables. The YAML never leaves Snowflake. No matter how good an LLM is, there are always complex edge cases or highly sensitive executive metrics that must be calculated perfectly every single time. To handle this, the YAML spec includes a section called the Verified Query Repository, or VQR. The VQR is a list of plain English questions paired with their exact, human-verified SQL queries. When a user asks a question, Cortex Analyst first checks if it semantically matches an entry in your VQR. If it does, it skips generating the SQL from scratch and instead intelligently adapts your verified SQL template. This builds immense trust with business stakeholders. Furthermore, you can flag specific verified queries with use as onboarding question true. Cortex Analyst will return these to your front-end application, so you can display them as clickable starter questions for new users. It guides them on exactly what the system is capable of answering. This flow diagram illustrates the verified query repository routing logic. When a user question arrives, the AI engine evaluates, does this semantically match an entry in the VQR section of the YAML? If yes, we take the top path. The system retrieves the heavily vetted verified SQL template, ensuring absolute precision for that specific metric. If no match is found, we take the bottom path, where Cortex Analyst falls back to its core capability, generating net new SQL using the broader context defined in the YAML tables and dimensions. Both paths converge to execute the query and return accurate results, giving you the best of both rigid accuracy and flexible generation. Sometimes, table definitions aren't enough. You need to enforce global business rules. That is where custom instructions come in. At the top level of your YAML file, you can add a custom instruction string. Here, you write plain English directives that Cortex Analyst must follow when generating SQL. For example, you can write, always round numeric currency columns to 2 decimal points, or if the user does not specify a date range, default the where clause to the last 12 months. This ensures consistency across all user interactions. For advanced control, Snowflake recently introduced modular custom instructions. This allows you to target specific steps in the pipeline. You can target SQL generation for data formatting, or you can target question categorization to establish security guardrails, for example, instructing the agent to immediately reject and block any questions asking for sensitive HR salary data. This diagram showcases the power of modular custom instructions within the YAML framework. The YAML file feeds into the module custom instructions block, which splits your directives into 2 distinct cognitive phases for the LLM. The top branch handles question categorization, which acts as a bouncer, interpreting user intent to block unauthorized topics and ensure a safe user experience. The bottom branch handles SQL generation. It applies your specific formatting rules, like rounding or default where clauses, guaranteeing a consistent BI output across your entire organization. Let's apply this to a real-time, highly valuable use case, global sales analytics. Imagine a VP of sales chatting with your internal Streamlit application. She asks, what is the month-over-month revenue growth for 2023 in Asia? In a raw database, this is a nightmare. The tables use cryptic acronyms like RevYDD and RegAPAC. But because you built a YAML semantic model, the system knows exactly what to do. The YAML translates the word revenue to the specific sum, RevYDD, metric, and maps the synonym Asia to the literal filter, RegAPAC. The SQL executes perfectly, but it gets better. Cortex Analyst supports multi-turn conversations. The VP types a follow-up, what about North America, Cortex Analyst automatically reads the conversation history, understands she still wants the month-over-month revenue growth, replaces the region filter based on the YAML definitions, and delivers the new chart instantly. You've just replaced a week-long BI ticket with a 10-second chat. Let's trace this interaction on the sequence diagram. The VP of Sales initiates the flow by asking her question in the Streamlit app. The app sends that prompt, crucially paired with the stage path to our semantic model.yaml to Cortex Analyst. Cortex Analyst does the heavy lifting, mapping the plain English to the YAML definitions and executes the SQL in the database. When the VP asks her follow-up question, "What about North America?" the app sends the follow-up, the conversation history, and the YAML reference back to Cortex. Cortex Analyst understands the contextual shift, regenerates the specific SQL, and returns the updated data back to the VP. A flawless, intelligent loop. To conclude, you don't have to write these YAML files entirely from scratch. Snowflake provides an AI-assisted generator directly in the Snowsite UI. You simply point it at your tables and provide a few historical SQL queries, and it will automatically extract the relationships, draft the column descriptions, and generate the YAML structure for you. As a best practice, always scope your models by domain. Create a marketing.yaml and a separate finance.yaml. This keeps the context highly focused for the LLM and ensures you stay well under the 2 MB file size limit. Start simple, test your results, and iterate. And from a security perspective, always double-check your grants. Your application role must have read on the stage and select on the base tables. I hope this deep dive empowers you to build incredible semantic layers. I invite all learners to like this video, subscribe to our channel, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final flowchart outlines the optimal development lifecycle. You begin by selecting your core tables and gathering example SQL queries. You feed these into the Snowsite AI generator, which outputs a draft YAML model. From there, you enter the review and refine phase. This is where your human expertise shines. You add your custom instructions and embed your verified queries. Once the file is perfected, you upload it to the Snowflake internal stage, and it is officially ready for Cortex Analyst to consume. Thank you for watching, and remember to visit quicktechie.com for more.